Recording. Yay! Okay, so we know that the atomic number is at the top of the periodic table. We know that the atomic number is also the number of protons. We know that in a neutral atom, the number of protons equals the number of electrons. Yes, sure. So what we're going to be doing is we're going to be filling this in for neutral atoms, okay? And so you're just going to go look up the symbol. You're going to go look up the atomic number. What do you know about the atomic number? Is there anything else here that it is the same as? It's the same as the protons, and that is the same as the electrons. So this is actually probably going to be the easiest table that you fill out, okay? Now, if by any chance you did not manage to fill out page 90, 91, you want to make sure you've completed those before you move on to this page, which is 92. So everyone, I want you to make sure you have finished 90, 91, 92, because we're going to move on to ions, and if you cannot do these ones, ions will be tricky. So I'm going to come around and check, make sure you've done 90, 91, and 92. If you're done, you can do page 93. And if you're done, you can work on you guys have electricity if you want to, right? some advice that I gave my other block, and I'm going to tell you this every day between now and Friday. This number, Friday is the next quiz. I don't know when we're done the unit, and I don't know when we'll be done the unit because we got long blocks and we got labs and things, and it's just confusing to me. This number at the bottom here, you will never use this number in grade 9. You get to use it in grade 11, but you will never use this number in grade 9. Don't use it. Don't ever use it. Just pretend it's not there. Okay? It's not there. It doesn't mean anything. Well, it does. It's the average mass of all the isotopes, but that is not useful to you in figuring out the number of protons and neutrons. So, if you have this side of the room, if you've got your little blocks on the periodic table, there's a number down at the bottom with a decimal. Are you going to use it? No, never. This side of the room, on the periodic table, your box. Down at the bottom, there's a number with a decimal. Will you ever use that number? No. No. Not until grade 11. Okay? All right. Not even grade 10. Grade 10, you won't use it either. Okay. We're just using mass numbers, and that one is atomic mass, which is an average. Whereas we want mass numbers.
I feel bad. No, you drew something. He drew something. He drew something. I think he drew something. You're becoming genius. This is not real. It's not even on this. It's on the radar. Actually, where is it, bro? This is not cool. I know where it is. Where is it? I know what page it is. I'll tell you at the end of the video. It might be the most genius man I've ever seen. Don't tell me. In social science. Flip. I'll tell you. Flip. What? She wanted to ask you how for like flip. Well, where is it? Flip. Keep flipping. I'm leading you right up. Where is it? One more. Where? One more. Where did you draw it? One more. Oh, thank you. Drew on the notes. No, I didn't. You guys are really wrong. So we're not gonna calculate the average.
No, if you want to do it as a bonus, like as an enriched thing, I can give you a little practice and have that as another section on the quiz. Okay? What am I doing? I am going here, and I am going here.
I didn't write. Alright, actually, did you write something like I don't want? I didn't write anything. I didn't write anything. Whoa, I'm getting praised. You're not getting praised. It's perfectly unreasonable. What is this? What do you write here? Minus electron? What symbol, bro? Tell me if it's the number. I didn't write anything. I didn't write nothing. Say yes. Wait, Milan, where's my pencil? I don't care. I don't know anyone. Alright, let me get the email about you. You left my phone open. I didn't leave it for you. What do you mean I left it open? Like you left the phone on. Wait, I thought it turns off automatically. What does it? Why is your phone like that, bro? Because I said it like that. What do you think? You're bad. You're bad. Alright, what's the email? Oh, right, this is so easy, bro. You can do this. That's Brian like this. One, getting nothing. Getting nothing. Nothing. Creating. It's concerning how much. Well, I have a quiz in every class. Yo, Milan, this week I have a quiz in like every class. Math, science, bro, look at the start of the year. There was so much quizzes every day. We had so many things. Right? Why you don't know anything? Ryan, you don't know anything. I don't like that.
Okay, my friends. We are going to go to page 94. 94. Page 94. Okay, what page are we on? What page are we on? What page are we on? Okay, and here we go.
Okay, what's an ion? People talk about ions all the time in chemistry, so what are they? Well, an ion is an atom or a group of atoms that have an electrical charge. Okay, that's all it is. Now, how does this happen? Well, inside atoms, there are two things that have an
Don't worry, we're
electrical
going to go
charge.
back.
There are protons that have a positive charge, and
Okay. So actually, if you could turn to 95 for just a moment. Turn to 95 for just a moment, and we're going to find out what is an ion. And we're going to write that at the top of page 95. No, it's just the next page. Oh, okay, sorry. I know you've already done this, right? Yeah. Never mind. Okay.
we talk about ions all the time in chemistry, so what are they? Well, an ion is an atom or a group of atoms that have an electrical charge. Okay, that's all it is. Now, how does this happen?
What is an ion? An atom or a group of atoms that has a electrical charge. Let's see if it's, oh, no, not there. Let's see if he goes, oh. An ion is an atom or a group of atoms
that have an electrical charge.
That have an electrical charge.
Okay, that's all it is. Now, how does this happen? Well, inside atoms, there are two things that have an electrical charge. There are
What are the two things that have an electrical charge inside an atom? Protons and electrons. Which one is positive? Which one is negative? What's the charge of a neutron? Nothing. Neutral.
protons that have a positive charge and electrons that have a negative charge. A lot of times in atoms, the number of protons is equal to the number of electrons. So the charges balance out, and you don't have any total charge. But sometimes an atom can gain or lose electrons, so that it gets more or fewer electrons and protons, and then the numbers don't balance out anymore.
Okay, so you remember the number of protons has to stay the same, because if you take out a proton or if you put in a proton, what happens to our element? It becomes a different element. But we can take out electrons, and if we take away an electron, we're taking away something negative. What charge do you think it becomes if we take away something negative? It becomes positive. You take away negative, it becomes positive. Now, what if we put in an extra electron? What if we put in an electron? It becomes negative.
And it's left with more negative charge because it has more electrons, or it's left with more positive charge because it has more protons. Let me give you a couple examples of how this happens. Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn two things in the zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots. If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal, because neutrons don't have a charge at all, they're neutral, so they're not important for what we're talking about here. Anyway.
So, yes. Why was it okay that we leave out the neutrons when we're talking about the charge of an atom? Because they don't have a charge. Yes.
Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus and it has 11 electrons flying around outside. So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like the sodium atom, we call it neutral.
Okay, so you can fill in the net or overall charge is 0. And what do we call something that has no charge? Neutral. So the net overall charge is 0, and something that has no charge is called neutral, or whatever it was they were yelling out in the hallway, weirdos.
Okay, but here's what can happen in sodium. You see this electron right here? It can lose this electron. It can lose it, and it flies off and usually goes into another atom.
Off it goes.
So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has...
Now, how many protons are in that atom? 11. How many electrons? Remember, it just lost an electron. There are 10. So do you have more positive things or more negative things? More positive things.
Has 11 protons, just like it did before. But now because it's lost this electron, used to be here, that was here. Now it's not here anymore. Now it only has 10 electrons. So now the positive and negative charges don't balance out anymore. And I'm left with more positive charge than negative charge. So this thing now is going to have a charge of +1, one more positive charge, negative charge.
Did you guys follow that? Why the charge is +1? Because there's one more proton than there is electron. Yes, of course.
And so I can write this, if I want to talk about the atom, I can write it as Na plus to show that it has a positive charge. Whereas this, when I'm talking about a neutral atom, I'll probably just write Na.
Okay, so those are the symbols. Remember, Na is the symbol for which element? Sodium, yes. Because chemists are lazy, and we assume that unless we have a charge of more than 1, we just write plus. Plus means +1, okay? You could write +1 if you wanted to. Certainly if you lose 2 electrons, that will give you a +2 charge, and you will write 2+ or +2, okay? Good question. Now, I want to stress to you the difference between this atom, which is neutral, and this ion, which has a charge. Yes? What happens is that sodium, its 11th electron is on its outer shell, okay? Because you have 2 electrons, and then you have 8 electrons, which gives you 10. And then on the outer shell, you have that one last electron. That last electron is quite far from the nucleus, yes? The nucleus is in the center. This one's quite far. And because it is not really close to that positive charge, it's held much more loosely, okay? Now, somewhere else, there's a chlorine atom maybe that has an empty spot in its outer shell because all the halogens have 7 electrons in their outer shell, and they want to have 8. So sodium will give its electron to chlorine, and now chlorine will have that extra electron. It will become Cl- because it gained an electron, and the sodium will have lost that electron, given it to the chlorine, and so it becomes +1. And then the two of them stick together because you have a positive sodium ion and a negative chloride ion, and those two attract one another, and that's what forms salt. Yeah? And in fact, where did I put it? Oh, there it is. The silver ones on here represent sodium ions, and the green ones represent chloride ions. So this is positive and negative, and positive likes to be beside negative, and negative likes to be beside positive, and positive likes to be beside negative, which is why if you look at salt crystals, they have this sort of square shape. Yeah, because they build, and it can become bigger and bigger and bigger and bigger. Okay. Now, if I were to take a piece of sodium metal, neutral sodium, It's a metal, it is shiny. I will show it to you next week during the long blocks. We're gonna do the labs next week because long blocks are kind of long. So it's kind of nice to have a lab. I was gonna do some this week, but then I thought, oh no, we need something entertaining for long blocks. Long blocks are next week, okay? Sodium metal, if you put it in water, it lights on fire and then goes bang. Can you imagine taking sodium and eating it? You have saliva in your mouth, you have liquid in your stomach, what would happen? Bang! You would go bang and that would suck. You would be like very ill, you might survive if you were given medical care, or you might not, it would be bad. But remember, sodium, when it's combined with chloride, now this is Na+, and sodium chloride is table salt. Is that okay to eat? So the properties, a chemical property of neutral sodium is that it reacts with water and explodes. This guy has a different chemical property. This +1 ion has a different chemical property. It will not react with water, it will not explode, and it's perfectly fine to eat unless you have high blood pressure, in which case you want to cut back on it, okay?
So Na plus here is an example of an ion. It's an atom that has a charge, and it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom. An ion. We call any ion that has a positive charge. Okay? And
whoa, what happened? Sorry. There we are. Okay.
Na. So Na plus here is an example of an atom. An ion. We call.
Okay, so the name of a positive ion is a cat ion, not a dog ion, but a cat ion. And I had my other class finish this up for homework, but I'm going to be doing the core competencies with them tomorrow, right? You're going to be doing it in your block 3 class, if you haven't already. So your homework is just, where did it go? Your homework is just to finish 90, 91, 92, and if you are done, and 93. Yeah. You're okay.
This is the only thing like I messed up because I knew this.
Yeah. No, you're good. Hi. Oh, thank you. Bye. Bye. See you. Your hair is so fantastic. I love it.